So the question is, how do we distinguish between, how do I identify the conjugate acid-base pairs? These are the potential answers on the question on your exam, and I don't like it for a reason that I'll show you. But let's look at these. The first pair, HNO3 minus and H2NO3. So what I've taught you to do is to look at these and see, do they differ by one H plus? So they have to differ by the number of hydrogens and the charge. And so if we look at this first one and compare it to the second one, we see the second one has an extra hydrogen, and it also is +1 compared to this. So if we took this HNO3 minus and added H plus, we would get H2NO3. Do you see that? Okay, what was tricky about this question and why I threw it out is because although looking at it that way, you would say, yes, that's a conjugate acid-base pair. The trick is that there is no such thing as H2NO3 because nitrate has a -1 charge, and nitric acid is HNO3. HNO3 does not have a -1 charge, and so they were tricking you, and I don't like to trick Chem 10 people, okay? I like to trick 3A students, but not Chem 10 students, okay? So by the rules that we talked about, the method of identifying, you would say, yes, that's a conjugate acid-base pair. So I'm changing, if I put this on the exam, on the final exam, I'm changing it. So that one's a no, but because those two things don't exist. Let's look at the second one, H2F and HF. Is the difference between these H plus? Yes, it is. Because if we took this HF minus and added H plus to it, then we get H2, and this minus would change into a 0, and we would get that. And so you would say, yeah, that's a conjugate acid-base pair. But what's wrong with it? What charge does fluoride ion have? -1. And if you pair it with hydrogen, HF does not have a -1 charge. So this was the same trick as the first one. Those substances don't exist. If they did, they'd be a conjugate acid-base pair. HNO3
so
exists.
You'll put ones that do exist?
I will put ones... I will make the question so that there's only one of these that differs in the appropriate way with the H plus. I won't put ones on there that follow part of it but then actually don't exist. So these first four, these two, neither of those substances exist. The formulas are just wrong. But that's asking too much to have you pull that in from back like chapter 5 kind of stuff in here. And so I don't want to make you do that. And this one too, that's just craziness. Let's look at the next one. HNH4 NH plus. Do these differ by H plus? No. You be careful. Because if you took the NH4 and you added H plus to it, what would you get? Well, you could get NH4 2 plus, right? So the H's are right, but the charge is wrong. Do you see that? Because if we took this and added H plus to it to get this one, because this one has more H's. So this has the correct number of H's to be the conjugate acid, but the charge is wrong. Because if we take NH4 plus and add H plus to it, we get HNH4 2 plus. You see that? So this, I think, would be fair game on your final exam. Because you don't have to be worried about, well, do those compounds exist? Do those ions actually exist? The rule of the H plus thing tells you, no, that's not right. Okay, so that one's not a conjugate acid-base pair. How about this next one? H2CN and CN minus. This one has two H's. See, we should be able to do this, add H plus to one of them and get the other one. If we take CN minus and add H plus, we would get HCN. Right? But they're giving us H2CN, so this one is wrong. Let's look at the bottom one. So how do you decide which of those to add the H to? Well, look at them. See which one is the more negative charge or which one has the fewer hydrogens and add the hydrogen to that one. You don't want to add the hydrogen to this one because you obviously won't get this one. So pick this one and add H to it. See what we get. Well, we're going to get H, PO4. And the charge is going to go from 3 minus to 2 minus because we're adding a +1 charge. And this is the same as that, and so that is a conjugate acid-base pair. Adding the hydrogen worked with these first two, but then the trick was that they don't actually exist. So I won't do that to you on the final. Does that answer your question? Sort of. You want to ask another question? Follow-up question? Yes.
So you add the charge, once you move the H over, you add one to the other number. Do you take one from the opposite one, or does it matter?
Well, here, let's do another example.
I need to do something with the exponents
Okay.
to see, I know we did it in the practice, but I'm not seeing it.
Okay, so what if I said, asked you, what is the conjugate acid of this? What's the conjugate acid?
Yes.
The acid has the hydrogen, the base doesn't. So to find the conjugate acid, we're going to add H plus and see what we get. So adding H plus, that gives us H2. The SO4 stays the same. And then the charges, we're going to add these exponents, the charges. +1 minus 1 adds up to 0. We're not going to write the 0. So this is the conjugate base, and this is, I'm sorry, that's not the conjugate base. This is the conjugate acid. Way to confuse people. And this would be the base. Are those two a conjugate acid-base pair? Why? Yeah, because they both have the same charge. They can't both have the same charge. This should have a -1 charge. Now it's a conjugate acid-base pair. Because if we take HS minus and add H plus to it, we get H2S. Are those two a conjugate acid-base pair? Look at the one that has fewer hydrogens and add a hydrogen to it and just see what you get. Now this had a 0 charge and this has a plus charge, so this is going to end up with a plus. And that is the same as this guy.
So when it doesn't have anything that's 0, it's not plus 1?
If there's no charge listed, it's 0 charge. It's neutral. Do one more.
With some goofy exponents.
Just drawing a blank.
Are they listed on the exam as acid and base, or are they mixed?
They're mixed.
So if just one of them, whichever one has more H's, that's the acid.
Right.
You start with that one and write that like you just showed us to see if we get it. And we add the hydrogen to the other one.
Are those a conjugate acid-base pair? They're not. So let's look at the one with fewer hydrogens. This time I listed it on the left. I drew those letters really weird looking, but sorry. HPO4 minus, if we added a hydrogen to that, I'm sorry, these aren't crazy. I can't do crazy exponents today, I'm sorry. You would get H2PO4. So that's not the same as H3PO4. So this is phosphoric acid. That actually exists. What's the conjugate base of H3PO4?
H2.
Yeah, we would have to subtract a hydrogen ion. So we get H2PO4, and then what would the charge be? A -1. Pardon me?
You're screaming around.
Oh, computer keeps falling asleep. Maybe I should pour Rockstar on it. Wake it up.
And the charge is what? 0?
-1.
Minus 1?
Maybe you should try. For the base.
This is the base
Okay.
because it has fewer hydrogens. So an acid is a hydrogen or a proton donor. The acid is the parent with the baby. The base is the babysitter who will accept the baby temporarily.
Would you have a minus charge on the? You could, huh? You could have one on the acid, as long
Yes.
as there are more H's on the acid
Right.
than the base.
And so we can have this. This acts as an acid also. What's the conjugate base of that? Take away a hydrogen ion. So subtract the hydrogen ion. And then we're going to get HPO4. And now the charge is going to be 1 less. It was 1 minus, now it's 2 minus. So HPO4 2 minus and H2PO4 1 minus are a conjugate acid-base pair. This is hydrogen phosphate. This HPO4 is hydrogen phosphate, and H2PO4 is dihydrogen phosphate. And then with, yeah, it's a weird family. Okay, so you feel better about that?